Good evening, everybody. Welcome to the Chem 170 Test Number 1 review with your host, me, Dr. White. Remember, in my class, there's no such thing as a dumb question. While I'm going through the review, feel free to ask questions. Anytime you're with me, feel free to ask questions. All right. Now, if you go to the lecture section of D2L, you'll find a file cleverly named Test Number 1 Review. I have it both as a Word file and a PDF file. Now I'm going to go through some of this, and I'll also answer questions. And you'll see after Test Number 1 why the review helps. Now, there's some definitions you should know. And those are, what is a hydrocarbon? That's a molecule with only carbon and hydrogen atoms. You should know also, what is a saturated hydrocarbon? Wow, that changed color on me. And that's a molecule with only carbon and hydrogen atoms, in which all carbon-carbon bonds are single bonds. And you should know, what is an unsaturated hydrocarbon? Excuse me. That's a molecule with only carbon hydrogen atoms that contain one or more carbon-carbon multiple bond, meaning a double or triple bond. Now, I'll never ask on a test or the final, what's an alkane, but I've used it in the videos when I teach. That's an acyclic saturated hydrocarbon. A means without, cycle, ring. Then there's cycloalkanes. By the way, Dr. White loves cycloalkanes. So does Mother Nature. And that's a mistake there. That should be cyclic saturated hydrocarbons. Now, one of the most important things this semester, and if you saw the video, I said it enough times, is you should know your friend for test number 1, 2, 3, 4 in the final. How many bonds to carbon? 4. Like, I got this finger fixed. How many bonds to carbon? 4. 4 bonds to carbon. That's always going to be one of your two big friends on all of my tests. Now, I taught you how to draw alkanes and cycloalkanes. And then I talked about IUPAC, which I'll never ask, but I did mention Uptimes International Union Pure Applied Chemistry. And that's the organization that came up with the nomenclature, meaning naming rules, and you should know how to use it. The first thing is how to find the longest chain, and then the alkane names for the longest chain from 1 to 10. It goes a lot higher, I think 1,000 or more, but in real life, 1 to 10 will do you good. After that, they use what's called common names. So you should know what's the IUPAC name for that molecule? 3 carbons, straight chain, propane. And let me open it up. Hopefully you found it. Again, this is in the lecture section of D2L. This file, which is called alkanes, IUPAC names, and number of carbons, you should know this table like you know your first name. Methane, 1 carbon, propane, 3 carbons, butane, 4, octane, 8, nonane, 9, decane, 10. What we mean by a straight chain is there, say 5 carbons pentane, and since there are 4 bonds to carbon, this first carbon has 1 bond to it, 4 minus 1, so it should have 3 hydrogens. This should have 2 bonds to it. 2 minus 2 is 2. Same thing here. This carbon has one bond to it. There's 4 bonds to carbon. 4 minus 1 is 3. So that's 3CH3. And that's a skill you should know. And you should know this chart. And hopefully, if you watched the videos, you would have picked up on that. Next, there are key alkyl groups called substituents. And I only teach a couple of the main ones. When there's a CH3 on a ring or a straight chain, that's called methyl. 2 carbons, ethyl. 3 carbons to the end carbon, N-propyl. 3 carbons to the center carbon to a ring or a chain, isopropyl. Then 4 carbons to the end, N-butyl. And when 3 CH3s are to center carbon, that's on a chain or a ring, that's T-butyl or tert-butyl. After the first test, I become a lazy organic chemist, which we are, and just call it T-butyl. Now, important tip, since you took the time to come here, rings, we don't show carbons. Every bend in a line is a carbon. So this has 1, 2, 3, 4, 5 carbons. If it was an alkane, it would be pentane. But it's a ring, so we use the prefix cyclopentane. Students forget to put that down. And I mark it wrong because pentane and cyclopentane are as different as night and day to me and any organic chemist. So remember on test 1, if you have a ring and you're naming it, put in the word cyclo as a prefix to tell that's a ring. Now, when there's only one substituent on a ring, we don't use a number. Let me do a better ring. Luckily, I have software that I use on my tests. So how do you name this? Why don't you try it, and then I'll do it. What would be the IUPAC name for this molecule right here? And give me a thumbs up when you're done. I don't think I have polling set up for this meeting. Oh, let's see something. Nope, no polls. All right. What do we see? We see a ring. It's got 1, 2, 3, 4, 5, 6 carbons. 6 is hexane. It's a ring, cyclohexane, and 2 carbons is an ethyl group. When there's only one substituent alkyl group on a ring, you don't use a number. That's ethyl cyclohexane. This is ethyl cyclohexane. All I've done is rotated 60 degrees. And Marion, that's why I'm going through some of these things. And if you go and look at the video for the test 1 review, I do similar because I want my students to do well. And let's do another practice. give the IUPAC name for this molecule, 3 points each, which if you've watched my videos, you've heard I say that. And tomorrow when you start test number 1, you'll understand why I say that. Hint. And like I said, give me a thumbs up when you're done. Well, I see one person done. I'll wait a little while for the others to finish. While you're doing that, let's see if I can set up polling real quick. All right, thanks for waiting. Let's get back to now I can do this. And if you're done, say yes, vote yes. Or if you want me to start doing the answer, also vote yes. All right, let's get going. Now, you have to find the longest chain. Carbons bonded together, linked together. This would be 1, 2, 3, 4. That's one chain, but another chain, 1, 2, 3, and this carbon is linked to that 4, and that's 5. Or if I came down here, that'd be 5. So the longest chain is 5 carbons, and that's pentane. And that's this chain right here. And then we have not one, but 2 CH3 groups. CH3 is methyl. When there are 2, we use the prefix di, dimethyl. And what carbons are they on? You start always from the end of the chain. Let me get rid of these numbers. You'll see why in a second. To give the overall carbon alkyl groups the lowest number. And if we start from this carbon, 1, 2, 3, the methyl groups are on carbons 2 and 3. If we start from here, 1, 2, 3, 4. Which are smaller numbers, 2 and 3 or 3 and 4? And time's up, 2 and 3. So this would be 2,3-dimethyl pentane. And you should know how to find the longest chain. I went through that in the videos. And here are the different alkyl groups, like I said. Now, you should know real world uses of alkanes. Natural gas methane is an alkane. Propane for your barbecue is an alkane. Gasoline is about 50–60% alkanes. Vaseline is longer alkanes. Baby oil are long alkanes. And real long alkanes, 50% of the weight of candles are. Now, the first reaction I asked was combustion. And combustion, you have an alkane, or it could have been a cycloalkane, oxygen. You get carbon dioxide, water, and heat. Now, since I will ask, give the product or products, heat is not considered a chemical product. So if I were to do the following, give the organic product or products are the following. I'll let you try it, and then I'll do it. If you can, when you're done, vote, please. Is everybody able to vote? I think so. All right, so what do we have here? An alkane. We're reacting with oxygen, and the general reaction, which I hope you memorize, alkane plus oxygen gives you carbon dioxide plus water, or you could have written water plus carbon dioxide, CO2, H2O first. And since this is an alkane, you're going to get carbon dioxide and water. You don't have to balance the equation ever in my class. Now, some of my best students, if you look at their tests, under each reaction, they write the general reaction, alkane, oxygen, CO2, water. Some of my best students, if you look at their tests, they don't write that, but they know it up here. Let's move on to alkenes and alkynes. Alkene is a double bond, 2 lines between a carbon. Alkyne is a triple bond. Now, you should know that a double bond has 1 pi bond and 1 sigma bond. Double bond, 1 pi bond, 1 sigma bond. You should also know a triple bond has 2 pi bonds and 1 sigma bond. Now, how do you name alkenes? The double bond, you name the longest chain with both carbons in a double bond as an alkane. You drop the ane and put ene. Now you need a number for acyclic, plus you need to say if it's cis or trans. And no number or cis or trans for cycloalkenes. But in a cycloalkene, one of the carbons of the double bond is always carbon 1, the other is carbon 2. Now for a triple bond, you find the, oh, I got another mistake. I apologize. Boy, I got to do better editing. You take the longest chain with both carbons of the triple bond, drop the ane ending of alkane like nonane, and drop the ane and put yne plus a number. You can't have cis or trans for a triple bond, and other than one time many, many years ago in a paper I saw, which wasn't that useful. That's my personal opinion. I've never seen a triple bond in a ring other than that one time. And why don't you give the IUPAC name for that compound? Your turn. And when you're done, please vote yes, so I know to continue. All right, I think everybody's done. Now, one of the things I've mentioned in the video a lot this semester, when you look at an organic molecule, look for what's different. What's not a carbon-carbon single bond or a carbon or hydrogen atom. That's where the fun is, the important part. Here we have two lines of double bond, alkene. How many carbons in the longest chain? 1, 2, 3, 4. Down here would be 5, but here's 5, 6. So the longest chain is hexane. It's a double bond. Drop the ANE, put ENE, hexene. And then the first carbon of the double bond closest to the end of a chain is carbon 2. Now, if you had a plane going through the double bond, or think of it, this is a line, notice these hydrogens are on opposite sides. And when you have two atoms or groups, one on each of the carbon, double bond, they're on the same side, that's called cis. When they're on opposite sides, they're trans. Therefore, this would be trans 2-hexene. And then as soon as we say that, all that's spoken for. Oh, look, it's a methyl group. And it's on carbon 4, so it'd be 4-methyl trans 2-hexene. Now, as I said many times in the video, there are two types of nomenclature question. On test 1, which I spent a lot of time in the videos, if we're face-to-face, I do the same thing. There are two types of nomenclature question. One is this type, and you saw that in the practice problems. Hopefully you've been doing the practice problems. And that is, give the IUPAC name, meaning the official name. I'll never ask you what IUPAC stands for, but for this class, you just have to know that means the official name. Now, the other thing is Draw the structure of the following molecule given a name, IUPAC, or one common name, which was acetylene. And why don't you try this one? Draw the structure for 4-isopropyl 1-dectine. All right, looks like everybody's done. How do you decode a name? You always start from the right and move left. YNE ending, triple bond. If that were ANE, 10 carbons. And you can start from either end. Most of you are going to call this 1. So I have a triple bond. This is 2, 3. On carbon 4, I have an isopropyl group. 3 carbons, the center carbon is bonded to the chain. And since I know there are 4 bonds to carbon, I can put in the rest of the hydrogens. When you're drawing structures, leave the hydrogens to last. It makes your life a lot easier. And that's how you do nomenclature, double and triple bonds. And if you go back and look at the video and the practice problems, you can see more examples, obviously. Now, when it comes to reactions, your second friend will be, first friend is how many bonds to carbon? 4. Your second friend is, do you break carbon-carbon single bonds? No, except for combustion, it's rare to break carbon-carbon single bonds. In my class, that's the only reaction where you break carbon-carbon single bonds. Double bonds, the pi bonds, I can break like that. Ooh, it's not there, it worked. I gotta change the battery here. So the first reaction to a double bond, you take a double bond reaction with hydrogen and catalyst, and the catalyst can be nickel, platinum, or palladium. You break the pi bond, and each carbon of the double bond gets a hydrogen. And what that means, what would be the organic product or products that are following reaction? You look for what's different, what's not a carbon-carbon single bond, or carbon or hydrogen atom should get your attention like that. And we've got a double bond. And the only thing I see now is a double bond reacting with hydrogen, H2, and platinum is a catalyst. Remember, the catalyst can be platinum, palladium, or nickel. If you work in industry, you use nickel. Academics, you have more money to spend, so you use platinum or palladium. You break the pi bond. Remember, this is one pi bond, one sigma bond, and each carbon gets a hydrogen of the double bond. Now, here are my two carbons of double bond. Do you break carbon-carbon single bonds? No. So I have 1, 2, 3, 4, 5 across, plus a methyl on this carbon right here. 1, 2, 3, 4, 5 across, my methyl. Here are my two carbons. Notice I broke the pi bond. There's only one bond between their single sigma bond or single bond. Each one gets a hydrogen, and there's 4 bonds to carbon, so I can write in the rest of the hydrogens. Remember, you don't break carbon-carbon single bonds. Now, in these two carbons, you wanted to write that CH2, you could, but since I'm the person grading the test, this is easier for you to do. It's one less thing you can get wrong, so that's what I'd recommend you do. If you want to put CH2, you can. Remember, you don't break carbon-carbon single bonds. Now, next reaction, same thing, but if you have a double bond, and X is the way organic chemists abbreviate halogens. And X2 is halogen gas, and X can be fluorine, chlorine, bromine, or iodine. Same thing, you break the pi bond, and each carbon of double bond now gets a halogen. Now, these are symmetrical additions. We're reacting the same, putting on the same atom on each carbon double bond. What happens if it's different? Well, the great Russian organic chemist Markovnikov found out how to channel that. That was a great lifetime achievement. And he came up with Markovnikov's rule. When you have a double bond reacting with HX, the hydrogen goes to the carbon with the most hydrogens in a double bond, and the halogen goes to the other one. And a way I learned, and it was in the video, I still remember decades later. Oh, I shouldn't have said that. You might know how old I am now. But anyways, my instructor, really good instructor, taught us the rich get richer and the poor get poorer when it comes to hydrogens in this reaction. And also them that has it gets it. And I'll let you try this one. What would be the organic product or products for the following reaction? 3 points each. One thing I'd like to ask those of you who are here tonight, when I'm done with the review, I'll shut off the recording because I'm recording this now. And I'll ask you to stick around because I'd like to ask you a few questions, see how things are going for you. It will not be recorded. It will never be put on YouTube. And let's take a look at this. What's different? What's not carbon? What's not hydrogen? What's not a carbon-carbon single bond? Double bond. We're reacting with HCl. Remember the halogens X. For this one, it's chlorine, bromine, or iodine. HF, hydrofluoric acid, is super dangerous stuff. I think I told the story in one of the videos about how that's the only project I ever refused to work on. And you break the pi bond. Remember, one pi bond, one sigma bond, and one carbon gets the H, the other gets the halogen. and it follows Markov-Nikolson rule. Do you break carbon-carbon single bonds? No. So I have 4 across. Here are my 2 carbons of the double bond. I break the pi bond. That methyl group is still there. This has 2 hydrogens. This has 1, which is the greater number. And time's up. Hopefully you pick 2. Markov-Nikolson rule says the carbon of the double bond with the most hydrogen gets the hydrogen, and the other one gets the halogen, in this case chlorine. And there are 4 bonds to carbon. The chlorine counts as 1 bond, so I can put in my hydrogens. And that's how you do it. Now, you can take a double bond, react it with H+. That's how organic chemists call an H+ is an acid catalyst, like sulfuric acid would be an example you could use here. There are other acids that I don't teach in this class that you could use. And we just show that in general by H+. And water. Now, water you can think of as H and OH. And you break the pi bond. 1 carbon gets H, the other gets OH, and it follows Markov-Nikolson rule. Now, a triple bond has 2 pi bonds and 1 sigma. And when we add hydrogen and catalyst, you break both pi bonds. And here, since organic chemists are lazy and we don't want to balance it, to show that you need enough hydrogen to do that, more than 1 molecule, we put the bracket, letters X and S, and close bracket. And here, that means excess hydrogen. Isn't that cute? I wonder who thought of that. It's really nice. And that means you have all the hydrogen in the world that anything hydrogen can react it will, the 2 pi bonds. And each carbon of the triple bond gets not 1, but 2 hydrogens. Same thing with halogenation. Again, we use that little abbreviation, bracket, XS, close bracket. And you break the 2 pi bonds, and each carbon of triple bond now gets not 2 hydrogen, but 2 halogen. And here's one for you to have some fun with. What would be the organic product or products for the following reaction? 3 points each. All right, my turn. If I look, what's different? What's not a carbon-carbon single bond or carbon or hydrogen atom? We have a triple bond. And all I'm interested, everything else comes along for the ride. What am I reacting with here? Iodine, which is halogen. And notice there's excess. And remember, X can be in this reaction fluorine, chlorine, bromine, or iodine, which in our case it is. This has 2 pi bonds, 1 sigma bond. You break the 2 pi bonds, each carbon of the triple bond gets 2 halogens, X. Now, do you break carbon-carbon single bonds? No. So I have 1, 2, 3, 4, 5 across. I have a methyl group. Here are my 2 carbons of the triple bond, which are these 2. Notice I broke the 2 pi bonds, and each one gets not 1, but 2 iodine. And iodine, like any halogen, counts as 1 bond to carbon. And now I know there are 4 bonds to carbon. I can fill in the rest of the hydrogens. And that's how you do it. Now, let's look at aromatic compounds. And I talked about Kekula, which I won't have on a test. But the simplest aromatic compound is benzene. And benzene has this structure. When you have a methyl group on benzene, you don't call that methylbenzene. IUPAC for both benzene and toluene took the eons used names for these molecules and say, we're not going to get those organic chemists change their name. We'll just call benzene or toluene. And remember, when you're doing reactions or nomenclature, if you don't show the bonds or the circle, that's cyclohexane. If I ask, draw the structure for benzene, if you write this down, that's cyclohexane. You have to put the conjugated alternating double bonds, or, which I don't like, because I don't like it as much as showing the bonds, but you put the delocalized pi bond ring, and that's benzene. Now, when you have disubstituted benzene and toluene, the methyl group counts as 1 substituent, we use the names ortho, meta, and para. Ortho is 1,2 disubstituted, meta is 1,3, para is 1,4. And I've now started showing you some new substituent names. Cl, chlorine on a benzene ring, or anything else, alkane, which would be a chloroalkane, is a chloro group. Fluorine is fluoro, Br bromo, iodine is iodo, and NO2, where the nitrogen is bonded to the ring, is called the nitro group. And if we look at this molecule, it's disubstituted. Oh, we got a benzene ring, but it's got a methyl group on it, so that's toluene. And we have NO2, that's nitro toluene. And notice their substituent is 1,4. 1,4 would be para. So that would be para-nitrotoluene. And then if you watched the video, I talked about 2,4,6 trinitrotoluene, otherwise known as TNT. And you don't see it on the test, but I talked about Alfred Nobel and how he made money to set up the Nobel Prizes. That won't be on test, but it's interesting to learn about. Now, when you have a benzene ring, you do not want to break those double bonds, because that gives it a stability that it doesn't want to give up. So for benzene, and unlike a regular double bond, like in the cyclohexane, you don't break the double bonds. One of the hydrogens on the ring is substituted for something else. This is called electrophilic aromatic substitution. and I'll never ask that on a test, but I'll use it now. And there are 4 reactions. The first one is halogenation, and you only see that for chlorine or bromine. You need a catalyst. You replace one of the hydrogens with the halogen. Now, if you had something on there, and this got next week's lab, you'll learn about directors. I don't teach it in a class, but I do show you it in a lab. And that's when there's something on the ring, it directs the incoming group where to go. Since none of you are going to be organic chemists, and I sort of know that, or you wouldn't be taking M170 if you were going to be an organic chemist, you'd be taking the 233, 234, 235 organic at CCC. I decided I'm not going to spend a week or 2 on directors when I'd rather spend it on things that are important to you, like later on fats and oils, carbohydrates, and proteins. So if we look at the second molecule, second reaction, this is the only one I can ask you. And that's nitric and sulfuric acid react with a benzene ring to put on a nitro group. It's important that's NO2. If you have a benzene ring, SO3, and sulfuric acid, H2SO4, you put on sulfonic acid group. I'll teach you later, being able to do this allowed chemists in the 1950s to create the molecules that are used in our laundry detergent. And this is the only reaction I can ask you here. Remember, let me show you something important. And this is putting on a nitro group. If you wrote this, wrong. That's nitrocyclohexane. You're never going to get it from that reaction. What? Oops, sorry about that. The right answer is either this one, where you show the double bonds, 3 of them conjugated or circle. And now this is nitrobenzene, the right answer. I had a student forget to put this or this on test number 1 a number of years ago, and she lost about 10 points for forgetting to do that. And I think she got an 85 where she should have gotten a 95. Boy, was she mad at herself, and she learned, pay attention. What you write matters. Now, the last reaction here is benzene with an alkyl halide, RX, and aluminum trihalide, and this is where you make a carbon-carbon single bond. And that's the last one. And the carbon with the halogen is the carbon bonded to here. And let's do one. I'll let you try one, Marion, because we're alone right now. And here's one for you to try. And when you're done, just give me a thumbs up if you want. And I'll ask a real big favor when I'm done. If you can stick around, I'd like to ask you a question or two. I will not be recording it. All right. So we look at this. What's different? Oh, a benzene ring. That's different. And then here, carbon-carbon, look for what's not hydrogen. What's not carbon? Ooh, a halogen on a carbon. This is an alkyl halide, RX. And this is my R group. R means something with carbons and hydrogen, just like in math, X and Y and Z are numbers. And I have aluminum trichloride catalyst. And what you get, actually halide, X can be, I think I have in this one, chlorine or bromine. The benzene ring, don't forget the bonds, and then the R group. And which carbon has the halogen? That one. So I have my benzene ring. We don't break carbon-carbon single bonds. So I have my 4 carbons. This is the carbon that had the halogen that's now bonded to the carbon, to the benzene ring, and we're done. With that, I hope this helped you. And I'm done, but I'm going to say goodbye, but Marion, stick around. And Gang Gesund, goodbye. I'll be